Every server has to shut down at some point, but in production, shutting down a server isn't as easy as flipping a switch. It's all about grace. You need to stop new requests from coming in, let ongoing requests finish, and also make sure that any background goroutines you might have complete their work, all without disrupting the system. So how do you design a graceful shutdown process that's reliable, efficient, and production ready? Let's break it down step by step. We have a simple golang program that starts a server on port 8000. If I go to the routes function, this simply creates a new servmux with a root endpoint pointing to a get home handler that simulates some work using time sleep and then writes back the string home. So this handler will take about 10 seconds to finish. Right now, if I start the server using gorun, make the request to the root endpoint, and then suddenly interrupt the program using Ctrl+C, the server shuts down immediately and the request is terminated. Ideally, when we shut down the server, all ongoing requests should finish their execution and return a response. To make this happen, we'll go back to our main.go file, we'll print out shutting down server, and call the server shutdown method. This requires a context and returns an error, which we'll simply print out. And we'll also print a shutdown complete message. Now if we try again, make the request, and close the server, it still doesn't work. That's because the listen and serve method is blocking, meaning that any code that comes after it will not be executed, not even when we press Ctrl+C. To go around this, we need to wrap the listen and serve call into a goroutine and have it run separately on its own. This way the main function can continue its execution. However, by allowing the main function to continue, we are immediately calling the shutdown method, which will immediately shut down the server. And that's not exactly what we want. We only want to shut down the server when we receive the proper signal to do so. For that, we can use the signal notify context, and this also takes in a context, and the signals we want to listen for. In our case, we're interested in sigterm and sigint. Sigterm is when the operating system wants to terminate the process gracefully, and sigint is when we press Ctrl+C. This returns a context and a stop function, to which we'll defer a call to make sure we release any used resources. Then we can use the context to wait for the done channel to be closed. And this will essentially block the execution until we get a sigterm or a sigint signal. Once we get the signal, the rest of the code will execute and the server will be shut down. Now if we try again and make the request, close the server, you see the request is still going, and we wait for 10 seconds, and there we go, the request is completed and the shutdown is also complete. Also, if I run this again and make a request, close the server, and then in a new window I'll do curl localhost 8000, the request will be rejected because our server is in a shutting down state, so new requests won't be accepted. Finally, regarding the context used, we could also leverage timeouts. Here where we listen for the shutdown signal, it doesn't make sense to use a timeout. We should only shut down when we receive the appropriate signals. However, here where we do the actual shutdown, we could force the server to close in a specific time frame. We could do context cancel, context with timeout, give it context background, and then let's say 5 seconds. We'll defer a call to cancel, and then pass context here. And this way the server will shut down in at most 5 seconds. So if I open the terminal and run it again, close the server, and now the request will fail because the server has been closed in 5 seconds. And here we have shutdown with error because the context deadline was exceeded. Just to be on the safe side, you could up this to like 20 seconds, and this should be enough. Now, while the server shuts down gracefully, there's still a gap we need to address. What happens to any running goroutines we might have? Let's explore. I'll go to handlers and create a new function, background work started, and just as before, we'll simulate some work using time sleep and then print out background work ended. Then we'll go to our get home handler and say go work in background to run the function as a separate goroutine. And now if we start the server and hit the endpoint, We get the response and the background work starts. But here's the issue. If we stop the server, that goroutine gets cut off mid-work, potentially leaving the program in a broken state. To fix this, we need a way to make sure all goroutines finish executing before the program exits. And for that, we'll use a wait group. Here's what we'll do. We'll go back to main and create a wait group variable. Then, back in the handler, before starting the goroutine, we'll call wait group add1 to increment the counter. We'll wrap the working background call inside a self-executing function, and now this wrapper function becomes the goroutine, and working background is just a regular function call. Finally, we'll defer a call to wait group done, so that when the goroutine finishes, it decrements the counter. And with this in place, we are now tracking the running goroutines. The final step is to wait for them to finish when the server shuts down. So back in main, just before exiting, we'll say waiting for goroutines. We'll call wait group wait, and this will block until all goroutines complete, and then print goroutines finished exiting. Let's give it a go. I'll start the server, make the request, and then stop the server. You'll notice the program waits a bit longer as the background work completes, and then it exits cleanly. And that was it. That's how you can gracefully shut down your Golang server. If you enjoyed this video, don't forget to like it, share it, subscribe, click the bell button, all that good stuff. Bye.